Hi, everyone. In this video, I'm going to discuss vector normalization. Basically, what that means is we're going to take a vector and we're going to convert it to have a magnitude of 1. And a normalized vector is indicated with this cap above it. A normalized vector is called a unit vector. Okay? And so here we have an example. We have this blue vector, which is components of x is 3 and y is 4. And we're gonna take that and we're gonna normalize it. But the first step in normalizing a vector is that we have to take the magnitude of that vector. And if you remember from before, we're going to calculate the length. We use Pythagoras theorem, and we take x squared plus y squared, take the square root of that, is going to give us the magnitude. So here we're going to take the magnitude, and the magnitude of this vector equals 5. All right, and what we're going to do to normalize it is once we've calculated the magnitude of vector A, we're going to divide both of its components by its own magnitude. So the A's x component is divided by the magnitude of A, and then the A's y component is divided by the magnitude of A. And the result of that is going to be a unit vector that always has a magnitude of 1. So a vector that has been normalized and is a unit vector pretty much doesn't have, its magnitude, it's still there, but it's 1. So we're not really using the magnitude in any of our math. We're mostly going to use it only for a direction. So it's very useful in a lot of formulas to simplify things because of the fact that a unit vector's magnitude is 1. And whenever we're using the math, we could have its direction impact other vectors without the magnitude doing anything to it, because the magnitude is 1. And just like if we took a regular real number, like the number 4, if we multiply 4 times 1, it's still 4. So if we take this vector and multiply it by another unit vector, the only thing we're going to do is alter its direction. We're not going to change its magnitude. So in other words, if this vector was pointing 90 degrees in the opposite direction, then we could use that in a formula to flip this vector or mirror this vector without having this influence anything with the magnitude. So all we're doing is changing its direction. And they're very useful for that. And also, I just wanted you to notice this gray circle that's around here. That's a unit circle, okay? It's got a radius of 1. And basically, any unit vector is going to fit within that unit circle because it has a magnitude of 1. So all it's doing is tracking only the direction, as I said before. And down here, if you look to bring back some trigonometry memories that you probably have about relationships within right triangles. And you take advantage of this in computer graphics and gaming very often, and definitely in vectors. So all of those things will come into play. And this will help you if you go down the road and want to learn more about how vectors work and get more into the math. So remember, a unit vector is indicated by having a cap over it. All right? And the way you create a unit vector is by normalizing it. And the way you normalize the vector is by dividing each of its components by its own magnitude. So again, if you like this video, please click like, please subscribe, and have a great day. Thank you.